Yes. Now, yesterday we completed chapter number 7, okay, prototyping embedded model. Now, chapter 8, techniques for writing embedded code. Okay, techniques for writing embedded code means what? You have to write a code to develop a software. Okay, now how to write that code? Okay, how to write that code? What are the functions you will use to do that coding? That we'll learn in this chapter, that is techniques for writing embedded code. Okay, so in this chapter we'll write the embedded code for your software as well as your hardware. Okay, but for software we have to manage the memory, because if you are writing a code, that code we have to store in a memory so that we can reuse that code afterwards, right? So for that purpose, memory management is most important tool when you are writing a code, right? So while learning memory management, we have to check what are the types of memory available to code, right? For example, we have a RAM, we have a ROM, we have a flash memory, we have a CD disk, okay, floppy disk. Here we are having a hard disk, okay. So this type of memory we are having. So optimize use of memory. Whatever the memory you are using, use that memory optimistically. Optimistically means more and more memory you can use, and like most of the using of your memory is called as your optimistic memory, right? So that optimistic memory you have to use in your memory management. Okay, so in that we will learn the types of memory, how to make most of your RAM, means how to optimize use of your RAM. As you know, we are having ROM memory and RAM memory, that is random access memory and read only memory, right? How to use that memory, that we'll learn in this chapter. Then organizing RAM, stack versus heap. As you know, our RAM can be used in stack also and heap also, right? So if we are using stack, how we store data, and if we are using heap, how we are storing the data. Now what is stack and what is heap, that we have learned in your data structure, right? Semester 3, what is stack and what is heap. Now how to use that stack to store the memory, and how to use a heap to store the data, that we learn in your memory management. Then after that, performance and battery life. Obviously, when you are using, when you are creating any software or hardware, at that time you have to check your battery life and performance of the system. Yesterday I already told you the performance of your system. If you are clicking on one option, that option will get automatically open in second. If you are not, if it is not opening in second, that means the performance of your system is very bad, right? So that performance and battery life, whatever the software you are using, whatever the battery you are using, that battery life should be taken in consideration when you are writing a code. Then libraries, yes, when we are using or when we are writing a code, as you know, in C++, Java, CSP, ASP.NET, okay, whatever the language we are using, each and every language, they have its own library. Every language it has its own library, right? So that libraries we have to take into consideration while writing your code. Then after writing a code, as you know, we are running the code, we are compiling the code, that means we are debugging the code, means our code is right or wrong, that we have to check with the help of debugging. And after that debugging, we'll store that code into some memory, that is hardware chip, you can say that is hardware chip or a software chip. Okay, so how, in this way you will write a code and store it. Okay, so after that, memory management. Now memory management, as you know, if you don't have too much memory, right? If you are initializing an array, If you are initializing array of 5, that means length of 5, if you are defining, that means beyond 5 length you cannot store your data, right? That means you know that my array is of only 5 length, only 5 length, okay? But if you don't know how much memory is available, but your motto is whatever the memory you have, optimize that memory, means use as much as possible of that memory. So in memory management we have to be careful while writing a code with respect to a memory management. So this is especially the case when you have no way to indicate that message to the user. That means you are not giving any message to the user that your that your memory is full, or that your memory is containing this much of space, right? Your memory is full or your memory is empty, your memory is half full. If you are not giving any message to the user will not able to know how much memory is occupied by the programs, or how much memory is occupied by the user. Okay, so if you are giving the warning dialog boxes, the second case, the computer user presented with one too many, that is one too many, that is low memory warning dialog boxes. Yes, in our phone also the low memory warning dialog boxes appears. As we increase our data storage, it will give you the message that low memory. Okay. Then on the other hand, on the other hand, an embedded platform with no screen or other indicators will usually continue blindly until it runs out of memory completely. In some systems or in some embedded devices, there are there are never indicators. They never indicate the user that the memory is like low or the memory is complete. It's directly gives the message that your memory is full and you cannot do anything now. In you have to delete some storage to generate or to check a new memory, to store a new data. Okay, so this type of problems are arises when you are doing the code or you are writing a program. So with this problem we can say that to overcome this problem of memory management, we can have many memory, like your RAM memory, like your ROM memory, like your flash memory, right? So according to the data storage, for example, if you want a data for a temporary basis, if you want to store a data for a temporary basis, you will use RAM memory. If you want to store a data on permanent basis, you will use ROM memory, that is read only memory. That means the data will be stored in a memory, but you can just read afterwards. You can just read that data. So for that purpose, you can use ROM memory. Then flash memory, when your temporary memory is like you have to access that temporary data frequently, like in a day or in a day twice in a day. If you want to access the data, then your flash memory will be used, right? So according to the data storage, according to the data, you can store your data into various type of memory, right? So while developing your software, you must try to debug this usage. Can be difficult, means when you are writing a code you cannot say that your data will be permanent or your data will be temporary. So that data that data we have to store into various types of memory. So first memory is your ROM memory. ROM means read only memory, refers to the memory where the information stored in chips is hard coded at the chip. This memory is hard coded into the hardware chip. As you know, there are many chips are available. We have learned in 8085. 8085 microprocessor we have learned. In that we have many types of chips and many types of registers are available. That in that register, your software code, whatever the coding, whatever the program you have done, that will be stored in that chip. So it is hard coded memory creation and can be only read afterwards. That means the data which is stored in RAM will be permanently there, but you can access that data at any time. You can read that data at any time, right? So this memory type is the least flexible. Why it is called as least flexible? Because it cannot change. It stores only the executable program, only the executable program code, and any data which is fixed, that is never changed. Whatever the data you want to store permanently, that means that data we will not change at any cost. That data will store in your ROM memory, that is read only memory. That's why the ROM memory is called as non-volatile memory. Non-volatile means what? Non-changeable memory, because that data, that memory will not change at any cost. It will not change. It will not change ever, right? So that memory will called as your ROM memory. Then after that, flash memory. Flash memory, it's semi-permanent type of memory. It's not permanent, it's not temporary, it's semi-permanent type of memory which provides all the advantages of ROM. That means you can store data in ROM, in your flash memory, that it can store information without requiring any power, and so its content can survive the circuit being unplugged. That means when your circuit is unplugged, when your power is not there, that time also you can access your data with the help of flash memory. With the help of ROM, you will require a power. Without power, you cannot do anything with this two type of memory, that is ROM and RAM. But in flash memory, if your power is not there, then also it will give you the content, whatever the content which stored in your flash memory. Then the content of flash memory can be rewritten a maximum number of times. Here comes the concept of reusability. Reusability means what? The data or the program which had written in memory, that can be reusable, or that can be more and more times of use. We can use that data more and more times, maximum number of times. That can be done with the flash memory. Whatever the data stored in flash memory, we can use that data in maximum number of times. Then reading from a flash memory isn't much different in speed as a ROM and RAM. The speed of ROM, RAM and flash is same. You cannot say that flash memory is slow, ROM memory is fast, RAM memory is fast. Okay, so you cannot say that. So your reading memory of flash, RAM, and ROM are same. Then it takes a few processor cycle, which means it's best suited to strong information that you want to hold on to, such a program executable itself or important data that has been gathered. Whatever the data, important data, or you can say whatever the information that you want to hold on a memory, like your flash memory, that will be used some processor cycle to display or to hold the data. Then random access memory, that is a RAM. Random access memory, as you know, in your phone, the RAM is important. In your phone, the RAM is important. Why it is important? Because in your phone, you are using multiple applications at the same time, right? So while using that multiple applications, the RAM memory is very much important, because whatever the softwares or whatever the applications you are using, that applications are minimized or temporary save in your RAM memory. Okay, so it requires power to return its content. When your phone is shut down, when your phone is shut down, your all minimized applications are like disappear when your phone is shut down. But when your phone is on and thousand of application if you have minimized, your RAM works on that application and it retains that application. But when your phone is switched off, when your phone is switched off, when your power is off, when your power is off, that all applications are disappear. That means that all applications are closed. But when it is on, when your power is on, when your phone is on, all the applications are like all the applications are retained in the RAM. So that's why in phone the RAM memory is very much needed because we are in phone we are using many types of application at one time. Okay, understood ROM, RAM, and flash memory.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so like system tends to have a lot more persistent storage than they do RAM, so it makes sense to keep as much in a flash memory as it is possible. Yes, because RAM and ROM needs the power power supply, and if your power supply is not there, your work will not be done, right? So for that purpose, most of the data will suggest that your data can be stored in your flash memory because can it can run without the power supply. Okay, so it's always better to store your data in flash memory because it can access at any time with the power also and without the power also. Okay, so you can also provide hints to the compiler to help it place as much as possible to the running program into flash. That means when you're writing a code, when you're writing a program, at that time you you have to indicate your system, you have to indicate your computer that most of the time you have to use flash memory. If that flash memory is full, then you can use RAM or ROM. That means you have to instruct your program, if instruct your system or compiler that whenever you are compiling the code, whenever you are executing the code, that time you have to use flash memory. So that's why it is much better to get this storage out of RAM and into flash because RAM is temporary memory. So if you are using temporary memory, if your power goes, if your system shut down, then your application or then your data will be disappear permanently. But in flash, the data will be stored permanently. Whenever you want to access the data, you can access it anywhere. Okay, so that is in C or C++ programming language. You do this by using the const keyword. You can use const keyword to use a flash memory. Means with the help of const keyword, you can say compiler that the data or the program we are writing that should be stored in your flash memory. The keyword lets the compiler know that the variable doesn't need to live in RAM because it will never to return to only read from. That means this keyword, the const keyword, lets the compiler know the variable doesn't need to live in RAM. That means it is not needed to store the data in RAM. It should store the data in flash memory. So const keyword we can use to store the data in flash memory. Then in Arduino, for example, provides an additional macro to let you specify that certain string should be stored in a flash memory rather than RAM. Now, how in Arduino we can say that the data is stored in flash and the data is not stored in flash, that is in RAM. So with the help of function f, you can say here wrapping the string in f tells the system that this is stored in flash memory. Means Whenever you are writing a code with f function, whenever you are writing a function or a code with the f function, that function or that code will stored in your flash memory. Other than that, other than that, if your serial.println function is used, this function will store your data into your RAM memory. That is your random access memory. Got it up to this? Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Okay. Now, how you use your RAM? Maximum use of RAM, how you can use. Okay. When you have only a few kilobytes or 10 or tens of kilobytes of RAM available, it is easier to fill up that memory, causing the device to misbehave or crash. If you know you have this this much of memory in RAM, you can use that memory. You can organize that memory, but you want to use as much as memory as possible to provide more features. Means whatever the data, whatever the memory you have in that memory, you want to use much of memory and much of your data to store that, much of your memory to store that data. So there is a trade-off between the maximizing RAM usage and reliability if your memory usage is deterministic. That is, if you know the maximum amount of memory that will be used. Whatever the data you have, that data needs to be optimized in your RAM usage, that is your temporary memory. So the way to achieve this result is not allocate any memory dynamically, that is while the programming is running. Because we know that of we have static memory of kilobytes or tens of kilobytes, right? So we will not again initialize the dynamic memory, that is runtime memory. Dynamic memory means runtime memory whenever you are where your code is running at that time your program is generating memory for itself to run the program, and that memory is called as your dynamic memory because it is generated while your program is running. But if you are having static memory, like for example, I have given you the example of array array of 5, that means that is static memory. Beyond 5 your data will not be stored, so that static memory you can use. But when your program is running and at that time it is allocating a memory, that memory is called as your dynamic memory. Okay, so to people coming from programming on on larger system, this concept is exotic because you can't predict how much your program is big or how much your programming is long, right? So as per the programming, your system will get the or your program will get the memory dynamically. That means your runtime memory. For example, when you are downloading some information from the internet, how could you possibly know beforehand exactly how large it is going to be? Because we don't know when we are downloading a program, if it is not written there that the file is of 10 kilobytes memory, 10 KB memory, or 10 GB memory, you cannot know what is the size of what is the space of the file to be taken in your computer. But if it is written, you can say that yes, I have this much of space, we can download this file. So whenever you are not knowing the space, whenever you are not knowing the like your memory management or your file management, at that time you can use your dynamic memory, because as much as your file long, that will that space of memory we can check, or you can we can initiate dynamically. The standard mechanism of on desktop or server system would be allocated just enough memory at the time you are downloading things when you know how much you will need. If you know that the file size is this much, then you can allocate your static memory to that file. Then in a deterministic model, you need to take a different tack. Rather than allocate space for an entire page, you set aside space to store the important information that you are going to extract, and also a buffer memory that you can use as a working area while you download and process the page. If you have, if you want to download entire page, your memory or your process will be distributed in small pages, or you can say in small parts. When one part is downloading, the other part will be in buffer memory. So that one part, after that one part is downloaded, that will stored in your permanent memory or RAM memory, and after that the buffer memories page will be downloaded after that first page. Okay, so likewise your entire page will be downloaded. Your entire page will be downloaded, and that process the entire project, entire page. That means the page can be refreshed entirely by doing this type of task, or you can say by doing this type of memory management. Rather than the downloading entire page into a memory at once, you can download it in a chunks. That means you can download that page in some little little parts, so that your page will be downloaded once and it will be refreshed at many times. And for that purpose, you can use your buffer memory. Buffer memory means what? Whenever your entire page is downloading, the buffer memory is storing some amount of data, and after that first page is downloaded, that buffer page will be downloaded and the buffer memory will be downloaded, and likewise your entire page will be downloaded into your system. If the format of the data you are consuming means that you know if something is needed only by the time you reach a later part of that file, you have to set aside space to save potentially useful segment when you encounter it. If you know that some amount of data or some amount of program we need to save, if we need to save in some type of memory, that data or that memory consumption is very much important or very much needed, because that data we have to segment, different we have to make different words or different parts when it is downloading. Means that some data we have to store different, or we have to segment different, and that data we have to use, and that data we have to store in some another memory, because that data we cannot combine in your flash memory or in your RAM memory. Okay, so that can be done in your memory management. Then after that, the general concept of arranging memory are used like stack and heap. We can know that in stack and heap we can store our data. As you know, in stack, one item is overlapped with the second, and then third, and then fourth. Likewise, your stack is preparing, right? Stack is work in LIFO manner, that is last in first time. Whatever the data entered last, that will be removed first. So that's why it is called as your stack memory. So the stack is organized just as the name implies, like stack of papers. Now, new items which are added to the stack go on to the top, and items can be removed only in strict reverse order. That means last in first order. The last item you enter or insert into the memory, that is only delete at delete first time. So the first things to be removed is the last item that was placed onto the stack. The processor has to track only the top of the stack, because insertion and deletion is done with the topmost position of the stack. Okay, we have learned this in our data structure subject. Okay, so the downside to this approach is that if you are finished with the particular variable, you can release the memory used for it only when you can remove it from the stack. You can do that only when everything added since it was allocated, it's removed from the stack too. That means If your data is stored in stack and that data is used, by the programmer, then you can remove all the elements of the stack and you can delete all the data from that stack, and you can reuse that stack for the new data allocation. Okay, but in stack the problem is that items that are going to survive for a long period of a time, when it is useful when it is useful, whatever the data is the at the like final stage, or you can say at the a long period, the data stored in long period, that can be stored in your stack, because that is, if it is not on top position, you will not delete that, right? So items that aren't going to survive for a long periods of a time, that can be stored in stack. Items that remain in constant use from the beginning to the end of the program, that can be stored in stack. That can be stored in stack because the data or the item is remain constant. The data which is stored in stack remain constant. You have to use that variables, that data constantly. So from beginning to the end. So that at that in that case also your stack will be used. Then global variables which are always available are allocated first on the stack. Yes, global variables which are the variable to use globally, or we can say that variables that uses frequently in the program, that we can store in stack. Then the parameters to the function get pushed onto the stack immediately, while the other variables are pushed as they are encountered. As and when the variables are required, that variables are pushed into the stack. Other variables which are not required for the program, that will be removed by the stack. See how we are organizing the RAM. Function A, variable A1 and A2. In function A, the variable A1 and A2 is there. In function B, the variable B1, B2, B3 is there. In function C, variable C1 is there. And in function D, variable D1 and D2 is there. Okay. When global variable is required, first of all, we'll allocate the global variable. In image, you can see in first image, the global variable is initialized. In second image, in second part, your A variables functions of A variable is initialized. In third, function of B variable is used, is pushed. Then in fourth diagram, function of C variable. Function C is pushed. That means inserted into the stack. In D, in fifth diagram, C is removed and D is insert. That means C function has deleted from the stack and D function has occupied C's function's memory. So in this type, your stack is working. If you don't need any function, then you can delete that function and that memory you can use by the another function. So here in fifth diagram, C is removed, and in space of C we have entered D memory, that is D function. Okay. Then after that, heap. The heap is, in comparison, enables you to allocate chunks of a memory whenever you like, to keep them around for as long as you like. In stack, we can use continuous memory, but in heap we can use chunks of memory, means small parts of memory, small parts of a memory, to organize the data. The heap is a bit like the seating area of a train, where you fill up the seats strictly from the front and have to keep everyone who is traveling as a group in a consecutive set. Like in a train, we are traveling, we are sitting like continuously, or you can say the seating arrangement is strictly from front to end, or you can say from left to right. This type of heap you get, this type of memory management or this type of data management you can use in heap. To begin, all the sets are empty. When at the first stage, or you can say at the beginning, the all seats are empty. As group of people arrive, as the people arrive into the train, the seats are being the seats are getting full. The block of memory, or the block of date, the block of chunks of memory will be occupied by the data, or in case of train, the seats are occupied by the people. But two possible problems exist. What are the problems? First, you might simply have more people to fit onto the train than there are seats. Means if you have less memory and your data is more than that memory, so that data you have to allocate, or you have to adjust into that strictly whatever the memory you have. That first problem is there, and second problem is there. Though you theoretically have enough presets for the next group of passengers, those presets are spread across to the train and aren't available in a continuous block. For example, like real life example, we can take it as a like uh, railway reservation. When the train is open, or when the coach are open, the reservation we are getting in sequence. Okay, all the seats we are getting in sequence. But when it is full, and at the last day, whenever you are arriving on the train, at that at that day, if someone is canceling the train, if someone is canceling the tickets, that particular seat is occupied by the new passenger. So likewise, HIP is working in this manner. It is allocating the data in linear sequence, but if any of the item or any of the data is removed in between, that data can be that space can be allocated by the new memory, or new data, or you can say the new arrival of a passenger, whatever data is there, that data can be stored in the data can be stored in this manner. Got it?